Hello. This presentation continues our discussion of correlation and regression involving categorical variables and focuses on how to interpret findings in logistic regression when categorical predictors are in the model. Let's learn more about logistic regression using the Medicare data set to create a model to predict hospitals that are the poorest performing on 30-day rehospitalization rates for pneumonia. The dependent variable in this analysis will be those hospitals that fell in the highest quartile on 30-day rehospitalization rates, which are coded as 1 and serve as the target group in this analysis. Hospitals that fell in the next lower quartile were coded 0 and served as the reference group in the analysis. We will use predictors we used when looking with these data in previous presentations. We will use 3 quality indicators used by Medicare, and these are the percentage of clients receiving smoking cessation counseling, the percentage of clients given antibiotics within 4 hours of admission, and the percent of patients receiving pneumonia vaccine. We will also include a geographical predictor that will contrast hospitals in the Northeast scored 1, our target group, with hospitals in the West scored 0, our reference group. These are data concerning the overall model reported by SPSS. The model chi-square, the Nagelkirk R-squared, and the classification success of the null model are presented. We would interpret these findings as follows. The null hypothesis that the model fails to predict group membership in the criterion in the population is rejected because the probability associated with the test statistic is less than alpha. The model improves classification success by 8.8%. Here are the results pertaining to individual predictors in our model. When we scan the significance column, we will note that only one predictor significantly and uniquely predicts group membership in the criterion. That predictor is region. Also note that the confidence interval for the odds ratio for the 3 predictors that are not significant all contain the value associated with the null hypothesis, 1. Also note that the predictors with positive B's have odds ratios greater than 1, even though they're not significant, and would generally be thought of as risk factors if they had been significant. And predictors with negative B's have odds ratios less than 1, and they would generally be thought of as protective factors if they are statistically significant. We would interpret the finding concerning the predictor region as follows. The null hypothesis that the predictor fails to uniquely predict group membership in the criterion in the population is rejected because the probability associated with the test statistic is less than alpha. Hospitals in the Northeast compared to hospitals in the West are 2.80 times more likely to be classified in the highest quartile of 30-day rehospitalization rates. Before we leave chi-square test of independence and logistic regression, I want to point out a process we've used with these procedures that we will see again as we learn about some of the new statistics in our field. The process is determining the fit of a hypothesized model by assessing whether or not it provides a better fit to the actual observed data when compared to an alternative model. In chi-square, we compared the fit of a model represented by the observed data to data representing the fit of the null model. We did this by comparing the observed frequencies to frequencies we would expect if the null model or the null hypothesis were true. One way to think of what happened when we rejected the null hypothesis in a chi-square test of independence is that we determined a model in which the variables are correlated fit the observed data better than the null model. And in logistic regression, we compared the classification success of the null model to the classification success of the proposed model. One way to think of what we learned when we rejected the null hypothesis in logistic regression is that the proposed model resulted in a better fit to the observed data than the null model. In many of the more sophisticated models used in our field, we will be comparing how well our proposed or hypothesized model fit the actual observed data compared to a null model or to an alternative model.